In this question, we are encouraged to find the derivative of ln 3x squared plus 1. This should allow us to find the integral of this function here. We can start differentiating d over dx of ln 3x squared plus 1. And following the derivative of ln, we should get 1 over 3x squared plus 1. Now we'll differentiate what's inside the brackets, and that's 6x. So we can tidy this up a little bit, and we just write this up 6x over 3x squared plus 1. From here, we want to find out the integral of 2x over 3x squared plus 1 dx. And we have a look at this and we say, well, what has that got to do with the previous derivative? If you examine the previous derivative, there is a huge similarity. The only thing that you want to do is change the 6 into 2. And we could do it by saying 3 times 2x over 3x squared plus 1. So it seems that this integral that we've got over here, we could rewrite this as 3 times the integral of 2x over 3x squared plus 1 dx. That seems to be the same thing. Good, so let's rewrite this again and down lower so we can do the integral. 3 integral 2x 3x squared plus 1 dx is going to be now the original function ln 3x squared plus 1. So now I just rewrite that. Ln 3x squared plus 1. Do not forget to put the plus c here. And because we don't want the 3 in front, we'll just rewrite this green function here. And we can now put the 3 underneath the 3x squared plus 1. So that will become over 3. Now, there is no point in dividing the c with 3 because it's just a constant. Which will be just another constant. It would be even tidier, I think, if we just write down a third. ln 3x squared plus 1 plus c. And this is our answer.